Okay, we're looking at conditional probability on my iMaths, and question 2 is all about a dinghy race. So it says, Alan is a member of a dinghy sailing team. The probability of strong winds tomorrow is 0.8. In strong winds, the probability of Alan's team winning is 0.7. In light winds, the probability of Alan's team winning falls to 0.25. Calculate the probability that Alan's team wins tomorrow. Okay, so there's two things we've got to think about. First of all, the condition of the weather. Two possibilities, strong winds or light winds. And then the weather being what it is, two possibilities, he will either win or he won't. So I've made a tree diagram to represent that information here. So it says the probability of strong winds is 0.8. So that's here on the tree diagram. Strong winds 0.8. And therefore the probability of light winds must be 0.2, because those two things have got to add up to 1, because it's certain to be one or the other. Those are the only two possibilities. Okay, so it says in strong winds, the probability of Alan's team winning is 0.7. So if the winds are strong, he's got a 0.7 chance of winning. And therefore, he's got a 0.3 chance of losing, because again, those two things have got to add up to 1, because they represent all of the possibilities in that scenario. However, in light winds, the probability of Alan's team winning falls to 0.25. So if it's light winds, he's only got a 0.25 chance of winning, and therefore a 0.75 chance of losing, because again, those things have got to add up to 1, because 1 represents the probability of a certain event, and he is certain that he will either win or lose. Okay, so that's the tree diagram representing the whole situation, and the probability of him winning or losing is conditional upon the weather, so it's conditional probability. So what you need to do with something like this is multiply the numbers out, as I've indeed done here, to get the probabilities of each of those possible 4 ways the thing can end up. So it can be strong winds and he wins, with a probability of 0.8 times 0.7, which is 0.56. It can be strong winds and he loses, with a probability of 0.8 times 0.3, which is 0.24. It can be light winds and he wins, with a probability of 0.05, or it can be light winds and he loses, with a probability of 0.15. And if you do that correctly, all of those things should add up to 1, because again, it represents all of the 4 possible outcomes, and we're certain that it will end up in one of those 4 ways. Okay, so calculate the probability that Alan's team wins tomorrow. Well, it can actually happen a couple of ways. So it can be strong winds and he wins, or it can be light winds and he wins. So because that's an either or situation, we need to add those probabilities up. So 0.56 plus 0.05 is 0.61. So in this case, it was 0.8 times 0.7 for him winning in strong winds, plus 0.2 times 0.25 for him winning in light winds. For one of those things to happen, then you needed the combination of 2 events, but it was an either or. He could win it either in strong winds or in light winds, so you added those up. Okay, given that Alan's team loses, find the probability that the winds were light. Well, in that type of a question, I like to bring in a Venn diagram. and put the information in that. So I've got two circles in my Venn diagram. I've got one about the wind and one about whether he wins. So the one circle for if the wind is strong and the one circle for if he wins. So right in the middle of the diagram, we've got the situation where it's strong wind and he wins. So that's the 0.56 from the tree diagram, 0.56 in the middle. It could be strong winds and he loses, 0.24. So that goes here on the Venn diagram, inside the strong wind circle, but outside the circle where he wins. It could be light winds and he wins with a probability of 0.05. So that's outside the strong wind circle and inside the circle where he wins, just there, 0.05. Or it could be light winds and also he loses, so that's outside the whole thing, 0.015. So it says, given that Alan's team loses, find the probability that the winds were light. So given that he lost, we know that he's not in either of those bits in the circle where he wins. So he's somewhere in the wrong pen. he's somewhere in the 0.24 or the 0.15. And then it says, find the probability that the winds were light. Well, in the 0.24, the winds were strong. So the question is really asking, what is the chance that he's in this 0.15, given that we know he's in somewhere in the 0.15 or the 0.24. So working that out as a fraction. So we know he's somewhere amongst the 0.24 plus 0.15. So given that he's in there, what proportion of that has him in the bit where the winds were light, the 0.15? So it's 0.15 out of 0.24 plus 0.15, which is the same as 15 over 39, which simplifies to 5 over 13. So there is a 5 out of 13 chance, given that we know he didn't win, that he's in the bit where the wind was light. So 5 out of 13 is our calculation. Let's just clear that from last time. 5 over, not like that, 5 divided by 13, and as a decimal that comes to 0.38. So let's just put that in the box and mark it, and there we go.